Good morning, students. Hope you are doing well. Welcome in video lecture of electronic devices and circuits. We already started unit number 2, MOSFET and its DC analysis, and in that, in previous lecture, we discussed the first point as the basics of MOS transistor and operation or MOS transistor operation. In that lecture, we discussed the exactly what is the MOSFET is there and how that depletion and enhance MOSFET it is categorized one that we discussed one and again in every category there is again n channel and p channel MOSFETs are there, that means PMOS and NMOS. These MOSFETs are considered one. That point we discussed in previous video lecture, and in that also that means the substrate it is considered one, and that substrate it is deposited with some silicon oxide, which is again that means that silicon oxide it is acting as the gate terminal and having the high input impedance, right? And that particular source and drain it is formed as the one channel by considering the uh, that particular substrate bar, they are deposited at the either sides, right? That means where the gate it is deposited by considering the silicon dioxide. Okay, sides of that particular silicon dioxide, you can see that we will see that particular construction in this today's video lecture. But just I give briefing that particular thing. Don't confuse that see channel it is considered as the entire channel is it is considered in the MOSFET. No, that is not the case. Here lightly doped, very lightly doped, that substrate material which is considered or very small conductive, or you can see that non-conductive type substrate material it is considered one, and on that this particular silicon dioxide by using that material that insulated silicon dioxide it is diffused one, and which is acting as a or which is considered as one type of a glass, and through that input signal it is given to that particular MOSFET, and accordingly due to that particular you can see that silicon dioxide this gate or input of this particular MOSFET it is having the high input impedance, because in that as it is the silicon dioxide it is due to that particular isolation consideration, there is no any current flow through the gate terminal, and due to that it is having the high input impedance. Okay, now today we are going to see the exactly the construction of n channel E MOSFET. See, in previous lecture I explained that there are the two types of the MOSFETs are considered one, mainly one depletion and another is the depletion MOSFET, and another is the enhancement MOSFET. Now, from that enhancement MOSFET, we are going to here today we are going to discuss the N-channel enhanced MOSFET. Now, before going to discuss directly the enhanced N-channel enhanced MOSFET or the construction of the N-channel enhanced MOSFET, today I am going to discuss the what exactly mean by the enhancement, how it is formed one, and how it is considered one, because that isolation or whatever the insulation it is considered or isolation it is formed for that particular gate terminal by using the silicon dioxide, that how it is working on what the exactly consideration is there, that we are discussing. We are first we will discuss here. Here I shown one figure in that one P type, or sorry, N type substrate. It is considered for that particular. Um, exactly, it is not considered for the N channel, but it is for the P channel. Here, N type substrate, it is considered one, and that substrate, it is again diffused one with silicon dioxide material, and this particular layer which is diffused on that particular substrate, it is isolated form in that particular thing, and it is acting one type of a capacitor having that particular inversion layer at the N type substrate, and that is acting one plate, and upper portion it is acting as the that insulated or a silicon layer that is acting as another plate. That means it is forming one type of a capacitor, right? And whatever the inversion layer, it is considered one. That whole inversion layer, it is having that particular, you can say that some charge, positive charge, you can say that it is considered one, and that particular, that plate, it is acting as the positive charge, and that particular, you can see that another which is considered as the diffused area, it is acting as the negative. So here to this plate acting as the to these plate are acting as the capacitor. So this kind of a construction, it is said as the MOSFET or MOS capacitor, right? Here N-type substrate, it is considered one, right? And this N-type substrate, it is acting as the depth. Now, the term enhance or enhancement mode means that voltage must be applied to the gate terminal so that that particular inversion layer can be created, where that a silicon dioxide material, it is diffused one, right? In between that, you can say that in between that particular silicon layer and that particular substrate, here that particular inversion layer should be created, and for that, here you have to apply some sort of the voltage, and here it is whatever the diffused area it is there, it is called as the gate, right? Gate terminal, it is called as the, here is considered as the gate terminal, but it is the acting as a MOS capacitor. Now, for MOS capacitor, the B-type substrate, a positive gate voltage must be applied to create a electron inversion layer, and for the MOS capacitor with the N-type substrate, a negative gate voltage must be applied to create the inversion, create the whole inversion layer. Here I shown you the whole inversion layer. So see, this particular layer, whenever you are applying this particular gate voltage, at that time this layer, it is enhanced one, it is increased one. That enhanced layer, it is considered at that particular insulated layer, okay, plate, right? And that insulated layer, it is considered at that particular substrate. This enhancement, it is called as the enhanced feature, it is called as the enhancement of this particular MOSFET. So due to this reason, it is called as the enhancement capacitor or enhancement MOSFET. We will see that thing also in next slide. Right now, here I shown the some sort of the cut section as well as the exactly structure of this particular MOSFET, how it is formed there, and how the layer it is considered one, and that particular how the isolation it is done by using the silicon dioxide insulation. That particular thing, it is shown in this particular figure. So here two figures are there, figure A and B. So this figure shows the simplified cross section of MOSFET and the gate oxide. Here the gate oxide, which is noted with the terminal VGS, right? And that gate, it is written on that particular figure A, right? So that gate oxide, it is formed one on this particular substrate, P-type substrate, because it is the N-channel figure. Okay, so the gate oxide, it is formed one, and the P-type substrate region, it is considered, which is acting as the MOS capacitor here, right? Which is acting as the MOS capacitor here. Okay, this entire thing it is we already in previous that means slide we should discussed one. Now apart from that, here additional two N regions are formed on this particular substrate, and these N regions are called as source terminal. That means left side of this particular screen, and the another is the drain terminal, which is right side at that particular screen in the figure A and discussing about the figure A. So this metal electrode it is considered as that particular source and drain here. Now they are diffused, they are doped on that particular substrate, right? Now the current in the MOSFET is the result of the flow of charge in the inversion layer, also called the channel region, adjacent to the oxide semiconductor interface. See here that particular middle portion, that is the oxide semiconductor portion is there, right? And that interface, okay, in between that interface, that particular you can see that enhancement it is happen one, inversion layer it is happen one, and due to that inversion layer, that current it is flows through the source to the or from the drain to the source. That is dashed lines are shown in as the in that it is n it is shown one, right? So these n regions are again connected with this particular thing. So here arrow one it is shown as the channel, okay, that layer, that inversion layer it is formed there, that is shown as the channel, right? Here the cross section is shown here, the polygate, right? It is polygate oxide layer it is formed there, drain metal is there, and source metal is there, which is again considered with the n type material, right? And the p type substrate it is considered one, p-type substrate it is considered. This is the entire construction of this particular E MOSFET, N-channel E MOSFET. Right now, we'll see how it is some sort of the working one. See here, length of this particular channel it is considered one L, right? And width of that particular you can see that substrate with having the this diffused area of gate as well as the you can see that source and that particular drain are fabricated on that particular thing, having some sort of the it is shown by arrow marks in figure A W, and the L the that particular channel width it is shown here. Now the channel length and the channel width are defined on that means it is shown in the figure here by mistake it is denoted as the E. You can say that you can consider E as well as the W, no problem, right? So the channel length of the typical integrated circuit MOSFET is the less than 1 micrometer, right? Which means that my MOSFETs are very small devices, right? And their thickness is typically in order of 400 angstroms or less, angstroms or less, 400 angstroms or less, right? That is the thing. Now in previous slide whatever the figure I shown one, in that figure A is one of the simplified structure I already said that particular thing, and B shows the more detail of the cross section of the MOSFET which is fabricated into integrated circuits configuration. Okay, the thick oxide, whatever the thick oxide is there, called the field oxide and is deposited outside the area in which the metal interconnect lines are formed. The gate material is usually heavily doped polysilicon. Remember that whatever the gate material is there, it is usually heavily doped one with the polysilicon that material. That means a silicon oxide material which is acting as an insulated material for that particular gate terminal. Now, even though the actual structure of the MOSFET may be firmly complex, the simplified diagram may be used to develop the basic transistor characteristics. Okay, so even though it is you are getting some sort of the complex, but it is simplified structure. It is considered one. Right now, here then how it is working and all that thing I will briefly introduce one. See here. With the zero bias applied to the gate, that means whenever the gate it is applied with the zero voltage, or you can see that there is no voltage, the source and drain terminals are separated by the P region. See here, P-type substrate it is considered one, and this source and drain I shown that particular L is the that particular length of that particular channel is that which is separating this particular source and drain, right? And this is the equivalent to back-to-back diodes. See here, back-to-back diodes it is considered one because PN again here PN. So this is considered as the back-to-back diode. In figure 2 it is considered one. The circuit in this case is essentially zero. Sorry, not circuit, it current. Sorry, the current in this case obviously it is 0 1 because both are acting as the that means they are opposite one and they are not carrying any current because gate is applied with the 0 voltage. If a large enough positive gate voltage is applied, see here once again I am saying here, as we are considering the N type of a MOSFET or enhanced MOSFET, here the gate should be applied with the positive voltage, right? So here gate voltage is applied with the positive voltage and electron inversion layer is created at the oxide semiconductor interface, and this layer connects the N source and N drain as shown in figure C. Here, figure C it is showing here that blue line from starting from this particular source, then this particular you can see that middle portion of that you can say that channel, okay, then again the drain like that it is shown here blue region, and dotted regions it is showing that enhanced layer it is produced one. Now here the current due to this what happens whenever you are applying that particular gate voltage and it is increased from 0 to positive volt, enough voltage you are applying towards that particular positive increasing towards the positive, okay, at that time this interface of that layer it connects that particular both source and drain, and due to that what happens, whatever the drain to source you are applied the external voltage, due to that current it is flowing through the drain to source here, drain to source here, right? This is the, you can see that some sort of the thing about the here. Okay, here even though you can see that there is a what I am saying that this particular you are applying the positive voltage to the gate terminal. Okay, here another point of that particular P side substrate it is again considered or it is grounded one. Already in first lecture I described that particular thing, right? Even though we are considering the gate terminal here with the positive voltage. Now, right now we will see the exact consideration. Now a current can then be generated between the source and drain terminals. I already said that, and since voltage which is applied to the gate terminal, it should be enough one. That means it should create that much inversion charge in that particular region, so that it is called as the, or it is whatever the voltage you are applying to the gate terminal, which is creating the inversion charge. This is called as the enhanced mode MOSFET. That means you must apply that particular gate voltage so that enhanced mode of the MOSFET should be considered one, or it is developed one, and that's why it is called as the enhancement mode, because of the inversion layer it is increased one, right? Now, and electrons inversion layer so okay, due to that electrons flow, that particular device is also called as the N channel MOSFET. Due to that inversion layer, the electrons carriers in that particular inversion layer electrons are, and due to that this particular device is also called as the N channel MOSFET. Okay, now the source terminal supplies carriers that flows through the channel, and the drain terminal allows the carriers to drain from the channel. Already explained that thing. Okay, for the N channel MOSFET, N or NMOS, electrons flow from the source to drain with the applied voltage to the drain to source, which means the conventional current enters from the drain terminal and leaves the source terminal, right? The magnitude of the current is the function of the amount of charge in that inversion layer. The magnitude of the current is the actually function of that particular amount of a charge in that inversion layer, okay, which in turn is a function of the applied gate voltage. That means due to the gate voltage, whatever the current it is flowing by, it is the function, it is the that exact, due to that exact the magnitude of current it is developed in that particular channel, which is passing from the drain to source. Since the gate terminal is separated from the channel by a oxide or insulator, there is no current it is flowing through the gate terminal. Remember that thing. Okay, and that similarly, the channel and substrates are separated by a space charge region. There is essentially no current through the substrate also. There is no essentially current through the substrate. Remember that thing. Even though that layer it is inversion layer, it is created in the substrate. Due to that particular channel and substrate are separated by the space charge region, that is the inversion layer, and due to that there is no current it is flowing through the substrate. Remember that thing, it is important point one, or due to that maybe you get confused one, right? So don't confuse this particular thing. Okay, got this thing, how this particular n channel MOSFET it is working on. Just I will brief once again. See here, whenever you are applying the gate voltage, initially due to the increase in that gate voltage from 0 to positive toward the positive voltage, due to that inversion layer it is generated or developed in that particular channel, that means in between the source and drain region, whatever that particular layer is there, that channel is there, that channel, in that channel that inversion layer it is developed one, and due to that inversion layer the current it is flowing from the drain to source, right? And due to that particular current flowing through that region, okay, that whatever the electron charge are there or that carriers are there, they are flowing from that source to drain terminal, right? So it is you can see the direction of the charge carriers, and that conventional current it is starting from the drain to source. The magnitude of the current it depends on the gate voltage. It depends on the gate voltage. How much you are applying the positive gate voltage for this N channel E MOSFET. It decides the, or you can see that it decides that exactly flow of the drain current. Okay, this is the one point. Though you are applying the positive voltage to the gate terminal, due to that particular silicon dioxide, which is insulated layer is there is no current flowing through that particular, you can see that gate terminal. No current it is flowing in that particular gate terminal. Remember that thing, right? This is the one thing. Another is that what I am saying here, the insulation layer which is acting as a channel, right, or that particular channel which is created here, and that in that particular insulation, or in that insulation layer it is created in that channel and the substrate, right, they are having some sort of the space charge region, and due to that there is no current flowing through the substrate. Remember that thing also. Remember that thing also. Understand what I am saying here? I am saying here. Okay, remember that thing, because it is important one. It is important one. Okay, so this is you can see that all about this particular construction, as well as how the N channel E MOSFET it is, you can see that functioning one, and due to that how the current it is flowing in that particular, you can see that N channel MOSFET, that is I explained today. So if you are having any doubt or query related to this, you can ask me, and be safe and be in touch. Study well. Thank you.